of trigonometry, the trigonometric functions. The diagram shows the graph of y equals to fx, where fx is equals to 3 over 2 cos 2x plus 1 over 2. And this is one complete pattern of the graph of cos. And state the range. So there's a very special technique. We know that cos, for any angle for cos, from -1 to 1. So this is the range for the cos function. So for the range, what you can do, simply you can replace this first by -1. So this whole thing, cos of 2x equals to -1 means fx is equals to, so in this way you can find the extreme values for, so this answer is coming as -3 over 2 plus 1 over 2 is equal to minus minus 2 over 2 is equals to -3 over 2, so is equals to -1, correct? And then next you put cos of 2x equals to the other value, which is 1. So simply by using these, you can find the range for any function. This technique you can apply for any trigonometric function. So 3 containing sine and cos equals to plus 1 over 2. This is 3 over 2 plus 1 over 2. So this is 2. So the smallest value for this graph is -1, and the largest value is 2. So range, you can write range. There are other techniques as well. So range is fx is greater than or equals to -1, less than or equals to. So quickly you can read the answer. The range is from -1 to. The other technique is that uh, as we have the function 3 over 2 cos 2x plus 1 over 2. This is the axis. So axis is here. So axis is 1 over 2. 1 over 2 is the axis. You can write 1 over 2 here. This is called the amplitude. This is the amplitude. So 1 over 2, 1 over 2 plus. So this gap is of 3 over 2. 1 over 2 plus 3 over 2 is equals to 2. Yes, the value is 2. And then 1 over 2, again here, 1 over 2 minus 3 over 2 is equals to -1. This is -1. So from -1 to 2 is the, so either approach you can apply. You can use the graph, or you can use this shortcut technique that just replace cos of 2x by 1 and -1, and you can identify the smallest value and the largest value for any trigonometric function containing sine and cos, and this technique can apply for any trigonometric function. Next, a function g is such that gx is equals to fx plus k, where k is a positive constant. The x-axis is tangent to the curve y equals to gx. So gx, this given function is fx. This is fx. There is another function gx, and gx is a function with, yes, this is 2 and this is -1 is here. The x-axis is tangent to, and this is positive, means moving up. So the graph is something like this. It should be, it can be like, so we have transformed, in other words, this graph 1 unit above. So because the condition is that x-axis is tangent to the curve, yes, this is the tangent, x-axis is tangent. So I've shifted this graph 1 unit above, and eventually this would be 3. So I've shifted this graph above, 1 unit above. So what I can write here, I can write, the question is, state the value of k. So as I move this graph, and this we know is the new is the translation. So here is the value of k, as we have shifted this graph 1 unit above. So the value of k is equals to 1. State the value of k, and hence describe fully the transformation that maps fx to this new function gx. So I can use any statement. I can use the translation. I can use the term translation as 1 unit above 0, 1, or what you can write a statement that this is a translation. This is a translation 1 unit upwards to get the graph of gx, because gx is here. fx plus k. So translation 1 unit upwards, or you can write parallel to y-axis. This is how you can describe. So first identify the value of k. In other words, that gx can be obtained by shifting this graph 1 unit above. Why 1 unit above? Because we want to make x-axis the tangent. Third, state the equation of the curve, which is the reflection, of fx in the x-axis. Give your answer in the form, yes, reflection. For the reflection, okay, simply we are looking for the equation. If y equals to fx is the graph, then for the fy equals to minus fx, we know is the reflection in x-axis. Reflection in x-axis. So I'm looking for y. Y is equals to minus fx. Fx is given. Y is equals to minus brackets. This is fx, the given function 3 over 2 cos of 2x. 3 over 2 cos of 2x plus 1 over 2. And when you open the bracket, so this is for the reflection in x-axis. So minus 3 over 2 cos of 2x minus 1 over 2. So here a and b are the constants. This is the value of a. A is equals to minus 3 over 2 and b equals to minus 1 over 2.